Hey, what's up guys? Hope you are doing well. Today we'll go through the various ways JavaScript provides to iterate through loops. Let's go! Okay, let's loop through the loops. And by the way, I'm using the Visual Studio Code editor. I've created a JavaScript file which I named loop.js. In order to run the code for this file and display the results here in the output, I'm using the Code Runner Visual Studio Code extension. And now let's start with the classics and more specifically the for loop. So let's create a basic for loop for let I equals 0, I less than, let's say 5, I plus plus, and let's just log I, console.log I. This is the starting point or initialization statement. In our case, we initialize the counter or loop variable to 0. Of course, variable could have any name, but it's like a convention to use I, which stands for index, as the loop variable, and we use the semicolon to end the statement. Next comes the continuation condition, which will be evaluated before each loop iteration, and if it evaluates to true, then the loop code block will be executed. Otherwise, loop execution will stop and program will proceed to executing the expressions following the loop. And finally, at the end of each loop iteration, we use this final expression to update the value of the loop variable before re-evaluating the continuation condition. In our case, we just increase its value by 1 by using the plus plus operator. We could of course alternatively use plus equals 1 or I equals I plus 1. All these produce the same result. They increase the value of the counter by 1. So let's save and test. In order to run the code, we right click and hit run code or use this shortcut Ctrl plus Alt plus N. And as expected, we get 0 up until 4 logged in the console. Why don't we also get 5? Well, because when I becomes 5, then the continuation condition is not met anymore. It becomes false and the loop execution stops. If we also wanted to print 5, we could use less than or equal to 5 here, and let's run. So this time we also get 5 logged in the console. Instead of going forward, we could of course go backwards, starting from 5, continue while I is greater than or equal to 0, and decrease I by 1 after each iteration. Let's save and see the result. Indeed, this time we get 5 to 0 instead of 0 to 5. Nice. However, in this tutorial, we'll mainly concentrate in looping through arrays. So let's define an array here, const my array equals, and an array is basically just a list of items. Let's say A, B, and C. And in order to loop through the entire array using a for loop, we have for let I equals 0. Since arrays are 0 based, meaning that index for first item is 0, for second is 1, for third is 2, etc. So for an array with 3 items, maximum index is 2, and in general for an array with n items, maximum index is n minus 1. So continuation condition should be while I is less than the length of the array, which is 3. However, for arrays and array-like objects in general, we have the length property, which returns the length of the array. So let's use this, my array dot length I plus plus. We are now ready to use indexes to iterate through my array items, and instead of just logging the index here, let's use template literals index I, and let's also display the value for the ith item. And how can we get the value for item with index I in my array? Well, that's simple. My array I. Nice, let's save and run the code. Indeed, for each array item we get the index and the value. We can also interrupt or break out of a for loop using the break statement. So for example, if I equals to 1, let's exit the loop using the break statement. Let's save and see the result. Indeed, we only get the 0 indexed element, since then I becomes 1 and loop is interrupted. And we can also use the continue statement to fast forward to the next iteration of a for loop. So, for example, if I equals to 1, we can use the continue statement to skip the execution of following expressions and move on to the next iteration. So let's save and see the result. Indeed, we get all items except for the item with index 1. Okay, let's proceed to the while loop. The while loop loops through a code block as long as a specified condition is true. The syntax for a while loop is the while keyword. In here goes the condition, and here the code block to be executed. So while this condition evaluates to true, this code block will be executed until condition evaluates to false. In this case, the loop will end and the expressions following the while loop will be executed. So if, for example, we used this condition, then this code block would never be executed. And on the other hand, if we used this condition, which obviously always evaluates to true, then this loop would never end. We would have an infinite loop, since this code block would be executed quote unquote forever, which would cause our browser to crash. Now, we usually use a variable with the condition, for example, while I is less than 5, and in this case we should first initialize the variable before the loop. So let I be equal to 0. Okay, so we initialize the variable, we have the continuation condition here, and let's log I. But before running the code, we should do one more thing, and that is increasing the variable value. Because guys, if we didn't do this, then let's see what would happen. I is set to be equal to 0 here, while I is less than 5 is a continuation condition. 0 is indeed less than 5, so this code block would be executed, and I, which is 0, would be logged in the console. Then this expression would be reevaluated, and 0 is still less than 5, so this would be executed again. Then it would be reevaluated, 0 would still be less than 5, and this would be executed, and you get the point. This would always be evaluated to true, and therefore we would get into an infinite loop. So in order to ensure that we would exit the loop at some point, we should increase I. Okay, let's save and run the code. Indeed, we get 0 up until 4 logged in the console. If we also wanted number 5 logged in the console, then we should rather use in the continuation condition while I is less than or equal to 5. So let's rerun the code. Indeed, this time we get 0 up until 5. And in order to loop through my array and log the index and value for each element in the array, let's see what changes we have to do. So let I equal 0. Yeah, we want to start from 0 index, while I is less than my array dot length, and we want to log the index and value for each element in the array. I++, this remains the same. So let's save and run the code. Indeed, we get the index and value for each element. Now, comparing the two loops, we can see that in both cases we have the initialization statement, the continuation condition, and the increment expression. So now you might be wondering when and why use one loop over the other. Well, we usually use a for loop when the number of iterations is known in advance, and therefore in our example it would make more sense to use a for loop since we know beforehand the number of iterations. While loop should be used when number of iterations is not known in advance and we only know the ending condition. For example, suppose we request the user to enter a number between 1 and 10, and while the user enters numbers beyond this range, we want to keep asking the user to enter a correct number. In this case, we don't know beforehand how many times this procedure will be repeated, and therefore a while loop would be the appropriate loop. Similarly to the for loop, we can use the break keyword to break out of the loop. For example, let's interrupt the loop if I equals to 1, so we expect only the first element to be logged in the console. Let's save and run the code. Very nice. And we can also use the continue keyword in order to fast forward to the next iteration of the loop. So if I equals to 1, by using the continue keyword, we skip execution of the following expressions and move on to the next iteration. However, can you spot the problem here? By skipping execution of this line of code, I will not increase and will still be equal to 1, and we will fall into an infinite loop. In order to avoid this trap, we should make sure to increase the value of I before continuing. So let's save and see the result. Indeed, we get all elements except for the element with index 1. Okay, let's move on to the do while loop. The do while loop is just a variant of the while loop. The only difference is that the loop will execute the code block at least once before checking if the condition is true. Then it will repeat the loop as long as the condition is true in a similar manner as the while loop. The syntax for do while loop is do. Here goes the code block be executed, and here while and the condition. Okay, and let's see how we can loop through my array using a do-while loop. It's very similar to while loop, so I will just copy paste things. This is the initialization statement. This will be the code block. And the while condition. So initially I will be set to be equal to 0, then this code block will be executed no matter what the evaluation of this condition is. Then if this condition evaluates to true, this code block will be executed again. If this reevaluates to true, this will be executed again, etc., until this becomes false. And in this case, the loop will come to an end and the program will continue executing expressions following the do-while loop. Okay, let's save and run the code. In this case, we expect all elements to be logged in the console. Alright, here we are. Now, just in order to show that this code block will be executed at least once no matter what the evaluation of this condition is, let's make sure that this condition will evaluate to false. So I is set to be equal to 0 here and increased here, so there is no way I will be less than 0, so this will evaluate to false. Let's save and see the result. As expected, this code block is executed once, then this evaluates to false, and the do-while loop stops. Okay, and that's all with the do-while loop. And of course, similarly to the while loop, we can use the break and continue keywords. Now, if you don't like the do-while loop, you can just use the while loop and easily get around this case if necessary. Excellent, and now that we are done with the classics, let's move on to the forEach method. The forEach method was introduced in ES5, ECMAScript 5, and it executes a provided function once for each array element in ascending order. So first the callback function is executed for the first element in the array, then the second, etc. Okay, let's loop through my array using the forEach method in order to log the index and value for each element in the array. So for each element in the array, this function will be called. The function takes up to 3 arguments. The first argument is required and corresponds to the value of the current element. So another good name would be item or value, but let's use elem, which stands for element. The second argument is optional and corresponds to the array index of the current element. And the third one is also optional and corresponds to the array the forEach method was called upon. In our case, it corresponds to my array. However, in our example, we won't make use of this, so let's remove it. And now let's log the index and value for each element in the array. So index is index and value is elem. Let's save and run the code. Indeed, we get the index and value for each element, and we could rewrite the callback function using arrow functions syntax, which was introduced in ES6. So we don't need the function keyword. These are the parameters, the fat arrow, and since we only have one statement, we don't need the curly brackets. Let's save and run the code. Okay, works as intended. And if, for example, we were only interested in the array element value, then in this case, we would only have one parameter and therefore parentheses would be optional. So let's remove them. If we run the code now, then we expect to get an error since index is not defined. Let's do it. Indeed, we get an error. Index is not defined. So let's remove it and rerun the code. Very nice. Now, why use the forEach method over the for loop? Well, the main argument in favor of forEach method is readability. And that's mainly because with the forEach method, we don't have to define and use a temporary variable as index in order to loop through the array. Moreover, with the forEach method, we don't have to think about the condition statement, avoiding the what we call off by one error, which is iterating one time too many or one time too few. On the other hand, a for loop, which does not necessarily involve an array, is more flexible since it allows to choose the iteration algorithm we want. For example, if we only wanted to loop through every second element in the array, all we have to do is increase I by 2 instead of 1 at the end of each iteration, which we can't do with the forEach method. Moreover, for loop is generally faster than forEach. However, forEach is still fast enough, at least in most cases. Browser support wouldn't be an issue since by now the forEach method is supported by all browsers. Needless to say that for, while, and do while loops are universally supported. Just keep in mind that arrow functions are not yet supported by all browsers, and therefore you might want to use this way to achieve cross-browser compatibility. And finally, contrary to a for loop, we can't break out of a forEach loop or continue to next iteration using the break or continue keywords. So if, for example, we tried to break out of the forEach loop if index is equal to 1, then we would get an error. Let's save and run the code. Indeed, we get an error, illegal break statement. Now in ES6, the for-of loop was introduced, which combines the conciseness of forEach loop with the ability to break and continue. So the for-of loop iterates over iterable objects such as strings, arrays, and array-like objects. And let's use the for-of loop to iterate through the elements of my array. So for let elem of my array, and again all we want to do here is log the value for each element. So let's save and run the code. Indeed, for each element in the array we get the corresponding value logged in the console. Now note that this loop creates a new scope in every iteration, and therefore we can safely use the const keyword instead of let, given of course that we will not reassign the variable inside the code block. So let's save and run the code. Works fine. Now the forOf loop doesn't give access to the index of the current element, and in most cases that's enough, and it's also shorter. However, we can also get the index using the entries method over the original array, which returns an array of index and value for each element of the original array. So let's do this. For const index and lm of my array dot entries, and this time we want to log both index and value. So let's save and run the code. Indeed, we get the index and value for each element. Nice, and as already mentioned, with the forOf loop we can use the break or continue keywords to break out of the loop or continue to next iteration. So for example, if index equals to 1, let's break out of the loop, save and run the code. Indeed, we only get the first element. And let's also test the continue statement. So if I equals to 1, let's continue to next iteration, save and run the code. Indeed, we get all elements except for the element with index 1. And before proceeding, let's check browser support for the forOf loop, which is quite good. However, the forOf loop is not supported by Internet Explorer. Also, the forOf loop is slower than the forEach method. However, in most cases it is still sufficiently fast. Okay, let's proceed to the forIn loop. The forIn loop iterates over all enumerable properties of an object, giving the property names. Note that it should not be used to iterate over an array where the index order is important, since it does not guarantee that it will return the indexes in any particular order. And although the forIn loop shouldn't be used to iterate over the elements of an array, just out of curiosity, let's use it to loop through my array. So for let, and instead of lm, let's use property. Since the forIn loop loops through the property names of the object, in the case of an array, property name is the actual index. So for let property in my array, again, let's log the index and value of each element. So index in this case is property and value is my array property. So let's save and run the code. In this case, the forIn loop loops through my array, keeping the correct order. However, as already mentioned, this is not the correct usage of the forIn loop, which should rather be used to iterate over object property names. So for testing purposes, let's create an object and loop through it using the forIn loop. Const my object equals, and let's name the first property A and give it the value 1, second property B with value 2, and third property C with value 3. And now let's use the forIn loop to loop through my object via property names, and let's log the property names. And the corresponding values. We get the values using the property names as keys. So let's save and run the code. We get the property names, however we don't get the value because I forgot to change my array to my object. So let's save and run again. Nice, now we get the property names and the corresponding values. And similarly to the for of loop, we can use const here instead of let. Let's save and run the code. Excellent. And regarding the browser support for the forIn loop, we can see that it does quite well. And that's all basically. We won't expand any further. However, before wrapping up, let's try to test the difference in speed between different loops. For starters, let's define the number of iterations. Let's say 1 million, 1, 2, 3, 4, 5, 6. And let's also define an array with the same length. This creates an array without items. All its elements are undefined, but with a given length. In order to capture the elapsed time, we'll use the console.time method with some label combined with the console.timeEnd method with the same label. So, for example, in order to time 1 million iterations using the for loop, let's name the label for, and let's create the loop here for let I equals 0, I less than num, I plus plus, and I'll keep the loops as plain as possible so that time won't be affected by other factors, so I will leave this empty. Let's save and run the code. So it takes about 7 milliseconds for 1 million iterations using the for loop. This is too fast. I don't know how reliable results will be. Maybe we should increase number of iterations. And by the way, I'm just using an average laptop. But anyways, let's also add the other loops and see what happens. Working in a similar manner and doing the bare minimum, let me speed code this part in order to spare you some time, and I'll be right back. Alright, so we have the for, the while, the forEach, and the forOf loops. Notice that I didn't include the forIn loop since it has a different use. All for loops here can be used to iterate through arrays. So let's save and run the code. Okay, first observation here is that all loops seem to be quite fast. The forOf loop, which seems to be the slowest, performs 1 million iterations in about 34 milliseconds. So if you don't expect to have more than a million iterations, then maybe speed shouldn't be a determining factor on which loop to use. Unless, of course, speed is very important for your program and every millisecond counts. Now, since loops are completed very fast, especially the first three, I would suggest to increase number of iterations in order to be able to maybe jump to safer conclusions. So let's make it 10 million iterations, save, and let's run. Okay, now we are talking. The while loop is the fastest with approximately 7 milliseconds for 10 million iterations. Next comes the for loop, which is again very fast with approximately 15 milliseconds for 10 million iterations. The for loop is about 2 times slower than the while loop. Next comes the forEach loop with about 55 milliseconds for 10 million iterations, quite tolerable I think. The forEach loop is about 3 to 4 times slower than the for loop. And finally, the forOf loop, which is the slowest, takes about 274 milliseconds for 10 million iterations, which is about 5 times slower than the forEach loop. And I think that at this point, speed starts becoming an issue especially for the forOf loop. Nice. However, just to be more confident about the results, let's increase number of iterations to 100 millions. Let's save and run the code. That took a while. Okay, what I mainly was interested about was the order. So these two are together. This time while is a bit faster than for, but not twice as fast. Doesn't matter because they are both very fast and difference is insignificant. Then comes the forEach and then the forOf. Nice, let's end our little experiment here. So in this video we've discussed the various ways JavaScript provides to iterate through loops. We've been through the for, the while, the do while, the forEach, the forOf, as well as the forIn loops. We mainly concentrated in looping through arrays, and at this point we should mention that besides these loops, modern JavaScript also provides many methods for working with arrays, such as map, filter, reduce, sort, sum, every, etc. That's all for now guys, hope you got some value out of this video. For any questions, suggestions, or just to say hi, please use the comment section below. Hit the like button if you like this video, subscribe if you want more. Till next time, keep coding, keep improving, and enjoy the journey. Take care. Bye.